Karibu SolidWorks Tanzania. Yeah, so this is the new presentation. It's special for our industrial automation series and playlist. And in this presentation, tunaenda kupata a little bit of an introduction on digital electronics focused on logic gates. So logic gates is one of the most useful section of digital electronics ambayo iko very compatible na PLC programming. So kama tulivyoangalia kwenye PLC pale, tuliona kwamba kuna kwenye CPU kuna component inaitwa arithmetic logic unit. Ile pale sasa inafanya calculations and logical executions basing on these logic gates principles, right? So let's start over. So in this chapter tutaenda kuangalia what is an inverter, tutaenda kuangalia an NAND gate, an OR gate, and if the time allows tutaangalia NAND gate, NOR gate, and the exclusive OR and the exclusive NOR gates. All right, so let's start with it. So begin with an inverter. So inverter, shortly, an inverter is a node circuit. Ni circuit ambayo ina perform operation ambayo inaitwa inversion ama complementation. So inversion ama complementation inamaanisha is the negative of the input. So we know in an input that's a digital input, we have either a 1 which is high or a 0 which is low. So if you have an inverter in your circuit or a node circuit, what it does is if you have high on the input, then you'll have low on the input, right? So it reverts the signal given. If it's a yes, then it says it's a no as output. Yes on the input, no on the output. A 1 on the input, a 0 on the output. And vice versa, a 0 on the input, a 1 on the output. So we have a variety of symbols that represent an inverter. Okay, so standard logic symbols. These are standard logic symbols, which are distinctive shape symbols. It can either be like this or like that. And then rectangular outline symbols, it can either be like this or like that. All right. So as you see here, this means a not. Okay, so if we have an A, so an output will be an A bar. Okay, but if we have an A bar, we will have an output of an A. All right, so that's what an inverter do. So it say the negation and polarity indicator. So the negation indicator is a bubble, this small bubble here, kwenye standard representation of a NOT gate. It indicates the inversion or complementation when it appears on the input or output of any logic element, right? That's what it does. So generally inputs are on the left, kwenye hizi logic symbols, inputs are on the left and the outputs are on the right. So when appearing on the input, the bubble means that a 0 is the active or asserted input state, and the input is called an active low input. So when appearing on the output, the bubble means that a 0 is the active or asserted output state, and the input is called an active low output, right? That's just an explanation on the inverter operations. So we have something called the truth table. Truth table ndo sehemu ambayo tunaangalia references ama correlations between the inputs and the outputs. So for an inverter, tumesema if we have a high on the input, then we will have a low on the output. And if we have a low on the input, then we have a high on the output. So this is the basic principle inverter operation. When the input is low, let's say a 0 input, the output is high. So if you have 0 on the input, you have 1 on the output. And when the input is high, a 1, the output is low. then you have a 0 on the output, thereby producing an inverted output pulse. So ukiangalia hapa, this is a pulse drawing of that shows the operation of our inverter. So you see here we have a common normal inverter, or a NOT gate. So you see we have a pulse. This is a low. Then we have a positive going pulse. Then we have a high. Then we have negative going pulse. Then you have a low. So between T1 and T2. So then if we enter this pulse through this inverter, then at the output, then this low becomes high and this high becomes low. So we have a high and low, right? So we have, you see this part was high here, now here it's low, it's inverted. This part was low here and this was low here, now it's high here and high there. Okay, so here this is the truth table. So input is low, output is high, and input is high, output is low. I think you have captured the idea here. Okay. So hapa amejaribu kutoa an example of a waveform. You can work on it. Like it says here, a waveform is applied to an inverter. This is a waveform. You can see low to high to low to high to low. Determine the output waveform corresponding to the input and shows the timing diagram. According to the placement of the bubble, what is the active output state? All right. So if you have here low to high, then we know for sure tukiingiza kwenye inverter, this whole waveform will be inverted into lows and one high. So we have hapa two high, one low. Kwenye output tutakuwa na two low and one high. So let's see the solution here. So the solution here is like this. You see this is the given waveform, and this right here is the output as it has passed through the inverter. So the active or asserted output state is 0, right? The output state is 0. Okay. So this is the complementary representation of an inverter. If you have an A on the input, then you have an A bar on the output. An A bar represents a negation of an input A, or an inversion of an input A. That means if A is 0, A bar will be 1. If A is 1, A bar will be 0, and vice versa. So an application. So for example, shows the figure below shows a circuit for producing the ones complement. So ones complement is to the inversion of an 8-bit binary. The bits of the binary numbers are applied to the inverter input, and once a complement of the number appears on the output. So you see here we have binaries 11010001. Then we see after passing it through the inverter, then a 1 become a 0, a 1 become a 0, a 0 become a 1, a 1 become a 0, a 0 become a 1, a 0 become a 1 again, 0 become a 1, 1 become a 0, etc. Okay, so now you see, mtu anaweza kajiuliza where exactly do we use the inverters in PLC programming? More often tunatumia inverters kwenye stop push button. So stop push button tunakuwa tuna NOT circuit, okay, ama NOT gate. Hiyo NOT gate inamaanisha an active is a, if you push the stop button you activate it, but then it deactivates the output. So unaona inafanya vice versa, kwamba the input on the post on the stop button is high but the output is now low. Okay, so pia tunaitumia kwenye emergency stops. Okay, badala ya kuwa labda na circuit ambayo ina switch and then an inverter, tunaweza kuwa tuna NOT gate peke yake ama inverter peke yake, ambayo if we activate it then ina deactivate output, lakini tukideactivate tuna activate output, right? Okay, here's some checkup if we have understood the inverter. So answer at the end of the chapter. So here there will be answers. So it says when a 1 is on the input of an inverter, what is the output? That's simple, right? Tumeshasema ina invert. So if we have a 1 on the input, then we have a 0 at the output, a high on the input, a low on the output. Okay, you can read the second checkup and then you can do it on your own. Just slow down and do it, and you will be able to do the solution for that. So that's it about the inverter or NOT gate. Then we go to the other gate called the AND gate. So the AND gate is one of the basic gates that can be combined to form any logic function. And an AND gate have two or more inputs and performs the what's known as the logical multiplication. So a logic AND gate is like a multiplication. Let's go down and see. This here is the symbol for an AND gate. Okay, input A, input B, output X. Ama inaweza kuwa represented by a rectangular qualifying symbol like this. So this is highly used. This is also used in some cases. So what's the operation of an AND gate? So this is the principle of operation of an AND gate. So inasema, for a two-input AND gate, output X is high only when inputs A and B are high. X is low when either A or B is low, or when both A and B are low. So inasema, for a two-input, maanake tumesema tunaweza kuwa na more than two inputs, tunaweza kuwa na 3, 4, 5, 6 inputs. So to have a high on the output, lazima all the inputs should be on the high signal. Na tumesema ukitaka kuelewa kirahisi, AND gate inakuwa ni multiplication ama dot product, kwamba kama input A ni 0, input B ni 1, then resultant ya AND gate ni input A times input B, manake 0 times 1, 0. That means kama ukiwa na input A is 1 and input B is 1, like see here, if we have a 1 here and 1 here, an output here will be high because it's a 1 times 1 is 1. 0 times 1, 0. 0 times 0, 0. 1 times 0, 0. So you only have a high output if both the inputs are high. Okay? Right. So this here is a truth table of an AND gate. So it says, let's say we have two inputs A and B, then output X. So input A 0, 0, 1, 1, input B 0, 1, 0, 1, then the output will be 0 and 0, 0, 0 and 1, 0, 1 and 0, 0, 1 and 1, 1. So you only have high when both the inputs are high. So to know the total number of possible combination of binary inputs, huwa tunatumia formula ni 2 power n. If we have one input, then possibilities of combination ni 2 power 1, so it's two combination. Two combination manake is either a high or a low, and that's it. Lakini if we have two inputs, like say two input variable, then number of possible combination will be 2 power 2, which is 4. Like here we have an A and a B, so 4 combination, a 0 and a 0, a 0 and a 1, a 1 and a 0, a 1 and a 1. That's the possibility of combination. Lakini ukitaka kuelewa kiurahisi, si unaona hapa tumepata 4 combination. Inamaanisha ni sawa na kuarrange binary number from binary 0, binary 1, binary 2 and binary 3. Okay? On the decimal numbers. Kwamba this layer here represent binary 0 for decimal number 0, binary 1 for decimal number 1, binary 1, 0 for decimal number 2, binary 1, 1 for decimal number 3. You get? So a possibility of a decimal number according to the input, that would be a 2 power n minus 1. Okay? Kwamba if you have two inputs, then you have a decimal number 2 power n minus 1, a 4 minus 1. So you have decimal number from 0 to 3. That's the easiest way. Kama ungekuwa na 3 inputs, ungekuwa ni 2 power 3. 2 power 3 is 8. Manake hapo ni sawa na kuzipanga hizi binary number from 0 in decimal form from 0 to 7, and then you write their binaries as per the 3 inputs. So for example, unaona hii hapa anasema develop a truth table for 3 input AND gate. So umeona we have how many possible combinations? A 2 power n, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So normally what happens here, kama tuna 3 inputs hapa kwenye truth table, kama tuna 3 inputs, then input number A, tumesema ni 8 combination. 2 power n is 2 power 3, which is 8 combination. Tunaigawa half. So A itakuwa ni 4 zeros, 4 ones. Alafu inayofuata inakuwa half of A. Maanake itakuwa 2 zeros, 2 ones, 2 zeros, 2 ones. And then the following itakuwa 2 single digits like 0, 1, 0, 1, 0, 1. But then hata ukisoma hizi number, this is decimal number 0, number 1, number 2 written in binary, number 3, number 4, number 5, number 6, number 7. And then our output as usual tumesema tukiwa tuko kwenye AND gate, all the inputs must be high to have a high output. So ukiangalia hapa only at this section here where we have input A high, input B high, and input C high, then you have a high output on the X. I hope you have captured that. Okay. Yeah, so this is an AND gate operation with a waveform input is the same thing. Hapa kwenye waveform tu unachoangalia ni corresponding waveform. Kwa mfano this waveform here has a high and a high. That means we will have a high output on this wave. We have a 0 and a 1. We will have a low here. That's why we have a low. We have a high and a high. Then we will have a high here, a high and a low. We will have a low here, low and low. We have a low here. And then you can just connect the waveform as you can see here. Okay, yeah, you can look more into this and you do this on your own, right? And this one too, you can look into this example here and you do it on your own. All right. So let's go to you see here, this is how they express an AND gate as a multiplication, like AB is equal to X, X is equal to AB. This is A and B. 0 times 0, 0 times 1, 1 times 0, 1 times 1 is equal to 1. So let's see an application of an AND gate. Let's see down here. So let's see a seatbelt alarm system. Tuangalie sasa hii seatbelt alarm system ambao ni mfano hai wa tunatumia wapi AND gate, where do we use the AND gate, ambao pia ni very good reference for a PLC operation. Okay, so it says here an AND gate is used in a simple automobile seatbelt alarm system to detect when the ignition switch is on and the seatbelt is unbuckled. If the ignition switch is on, a high is produced on A. So ukiangalia hapa we have this AND gate, we have ignition switch. Ignition switch inaweza kuwa on ama off. Seatbelt seatbelt mkanda wako ule unaweza kuwa uko unbuckled, haujawekwa, ama buckled, umewekwa. And then we have a timer. Okay, inaweza kuwa ni delay timer, right? Time delay before it sends an alarm. And then when the ignition is on, then it say high for 30 seconds. Like this timer should be on for 30 seconds. All right, so let's say this is the it will be high for 30 seconds. Okay, and then you will hear audible alarm circuit. So you'll hear alarm. So what happens here ni kwamba ignition switch ikiwa on, manake 1, A is 1, input A is 1. Alafu seatbelt ikiwa unbuckled, kama hujachomeka mkanda wako wa usalama, ambao hujachomeka seatbelt yako kwenye ile lock yake, manake B is also 1. Na timer inaactivatiwa na ignition switch, manake na timer pia ambao ni input C na yenyewe ni 1. Then an audible alarm circuit is on. Okay, so unakuta magari mengine yameongeza pia action ya uzito wewe unapokaa. Kwa mfano ukiingia kwenye gari, so hapa tunaweza kuwa tuna another input here for weight. Okay, kwa sababu ile blink ama alarm ya seat belt inatakiwa ijue pia kwamba someone has sat on that seat. Kwa hiyo kunaweza kuwa kuna uzito fulani ambao uko set minimum weight, let's say 10 kg, kwamba ikishakuwa kwenye hiyo seat then ina blink that the seat belt is not plugged au buckled. So mtu anavyoingia kwenye gari akikaa, maanake sasa tuseme tunapima uzito, tunaangalia kama umechomeka mkanda, na tuna timer ambayo ni ina delay, na tuna ignition switch. So mtu akiingia kwenye gari akikaa, uzito unakuwa activated, unakuwa high, that's a 1. Then tuna another input. Ukiweka ignition switch on, maanake that's another high. So we have 2 inputs high. Then kama hujachomeka mkanda, then we have another high. Hiyo ni input number 3 high. Then tunakuwa tuna delay timer. Then tuna timer ambayo inakuwa activated na ile on switch ya gari yako. Kwa hiyo inaanza kupiga labda alarm TT TT, like the seat belt is not plugged. Any of these, kati ya hizi input zote, yoyote ambayo itakuwa low, alarm itazima. Okay? Kwa mfano, ukichomeka tu seat belt, ukishafunga seat belt, manake umebako your seat belt. Ukiangalia hapa, ukibako your seat belt, then seat belt input inakuwa low, 0. Manake you have a 1 on ignition, a 1 on the weight, a 0 on the buckling of the seat belt, and a 1 on the timer. But then kwa sababu hizi zote sio 1, we have 0, na tunajua end gate, all the inputs must be high to give you a high output, then actually your alarm goes off, or ile blink ya put on seat belt ina fade away, inatoka. Happy you have captured how we have applied an end gate on a car seat belt. Okay, but just a checkup, when is the output of an end gate high? Hapa tumesema only when all the inputs are high, then we have a high. When is the output of end gate low? We have a low if any of the input is low. Describe the truth table for a 5 input. Okay, so 5 input manake in 2 power 5, and then you can do that on your own. After that, we go to another gate called the OR gate. So an OR gate is another of the basic gates from all the functions, logic functions are constructed, right? So here is a symbol for an OR gate. This is a famous symbol for an OR gate. And this is a rectangular outline with a O greater or equal to 1 qualifying symbol. Okay, so this is highly used. So what's an operation of an OR gate? So tunasema for a 2-input OR gate, output X is high when either input A or B is high, or when both A and B are high. And then output X is low only when both A and B are low, right? So kwenye hii switching ya OR gate, tunasema kama una input A na B, if any of those input is high, then you will have a high on the output. Manake this is an additional operation. It's a plus. So if you look here, if you have 0 and a 0 plus a 0 is 0. So you have low if both the inputs are low. All the inputs are low. But if any is high, then the output is high. For example, here a low and a 1, a low and a high, so 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Okay, so you have a high if any is high or all of them are high. Hope you have captured that. This is a truth table for an OR gate. So you see here we have a high here, a 1 and a 0, 1, a 0 and a 1, 1, a 0 and a 0, 0. So here this is just a waveform of an OR gate. For example, we have a high and a high, we have a high output, a 0 and a 1, we have a 1 as output, a 0 and a 0, we have a 0 output, a 1 and a 0, we have a 1 as output. Okay? Right. So you can try to look at this waveform. Unaweza ukaichora pembeni na ukajaribu kuredraw the output to see if it fits like here. All right. You can also try to do this one and you see if you can get the output waveform as it is seen here. This one too, you can try for these 3 outputs and see if you can have this waveform output as seen here. Okay, so kama nilivyosema, a logic expression of an OR gate is like A plus B. Pale mwanzo tulikuwa tuna AND gate ambayo tusema ni kama multiplication, tusema AB ama A dot B. That means an AND gate is a multiplication, but an OR gate is an addition. So an A plus B, that's an OR gate. So you can see a 0 plus 0, 0, 0 plus 1, 1, 1 plus 0 is 1, 1 plus 1, 1. Okay, here just some sample of how we write an output of this gate. This is A plus B. This gate will be A plus B plus C. This gate will be A plus B plus C plus D. That symbolizes an OR gate. Okay, so let's see an application of an OR gate, a real world example where tunatumia wapi hizi OR gate switching. Tumeona AND gate tumetumia kwenye seat belt ya gari, si ndio? Tunatumia logics. Okay, kwamba bana kama hiki na hiki na hiki vyote viko high, then you have a high on the output. If n is low, then you have a low output. So let's see for an OR gate. So anasema an application, a simplified portion of an intrusion detection and alarm system is shown. So tuseme mtu ana nyumba, ana makazi yake, anataka kuangalia kama kuna uvamizi kwenye maeneo yake ya makazi, anaweza akatumia OR gate. So kwenye switching, this is what happens. This system should be used can be used in one room in a home, a room with two windows and a door. Kwamba tuashumu kwamba una chumba ambacho kina mlango mmoja na madirisha mawili, labda kama nyumba ya kupanga hivi, kama self room, self contained room hivi rent, then unataka kuangalia kama kudetect kama kuna intrusion. So the sensors are magnetic switches that produce high output when open and a low output when closed. Umeona kwamba hizi switch zenyewe labda kwenye mwisho wa madirisha, labda madirisha yako ni aluminium, pale mwishoni kabisa kuna magnetic switch, ambayo hiyo magnetic switch ikiwa ziko interlocked, ikiwa imeshikamana, inatengeneza low output. Ikiwa release, ikiwa hajashikamana, inatengeneza high output. Okay, so as long as the window and doors are secured, the switches are closed and all three of the OR gates inputs are low. Kwamba as long as dirisha limefungwa na madirisha yamefungwa na mlango umefungwa, inamaanisha zile sumaku zote zimeshikamana, maanake zina produce low 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 0 0 0, maanake your alarm is off. Okay, so when one of the window or door is open, a high is produced on that input to the OR gate and the gate output goes high. Umeona kwamba mtu labda amekuja, mtu ambaye anataka kuingia kwenye chumba chako, akifungua dirisha, maanake sasa ile sumaku ambayo imeshika kwenye dirisha husika lililofunguliwa inakuwa released. Ikireleased ina produce high. Ikiproduce high, na tunajua OR gate ina produce high if any of the input is high. Maanake kama kwenye output yako inatakuwa isound an alarm, ama iwashe taa, okay, ama ipige king'ora, maanake king'ora kitakuwa activated provided any of those input imekuwa activated. Kama mtu amejaribu kufungua mlango, itapiga alarm. Kama amejaribu kufungua one of the windows, itapiga pia alarm. This is the layout of such alarm circuit system for intrusion detection system. Okay, I hope that was well understood. It's an interesting, very interesting logic. So let's do a checkup. When is the output of an OR gate high? Well, we know if either of the input is high, then you have a high on the output. When is the output of an OR gate low? When both all of the inputs are low, then you have a low on the output. Describe the truth table for a 3, so you can do that on your own. After that, let's go to the NAND gate, then a NOR gate. So before nadhani tuliangalia kitu kinaitwa inverter. So inverter tulisema inafanya inversion of the input. If it's a high, ina give out low. If it's a low, ina give out a high. So tukisema a NAND gate, it means that's an AND gate and an inverter. Kwamba unakuwa na AND gate, alafu the output of an AND gate is inverted. Hiyo ndio unakuwa na NAND gate. Ama inamaanisha not AND gate. Okay? Alright. So this here is an AND gate. So this is the symbol. Unaona hapa unaweza ukaweka tu a bubble here to indicate kwamba the output here is AB bar. Kwa mfano ukiangalia hapa, this is exactly similar to AB. You have an AND gate and a NOT gate. Then the output here inakuwa an inverted output of the AND gate. So what's the operation of an AND gate? So it says here, output X is low only when the inputs A and B are high. X is high when either A or B is low, or when both A and B are low. Umeona? So unaona hapa inavyoonekana ni kwamba, so for a NAND gate, a low and a low gives a high. Kwa sababu kwa normal AND gate, low times low, 0 times 0 ni 0. But if you negate it, ama you invert it with this bubble here, then a 0 and a 0, 0 gives 1. So you see here, a 0 and a 0 gives you 1. A 0 and a 1 was supposed to give you a 0 in an AND gate, but then if you invert it with an inverter, then you have a 1. So it's like a flip of an inverse of all the output of the AND gate. I hope you have understood that. For example, here you have A and B, and then you have the output here. So you know in an AND gate, a high and a high gives you a high, but then you invert it to have a NAND output, then it's a low. Then here a low and a high actually gives you a low in an AND gate, and then you invert it with an inverter for a NAND gate, gives you a high, etc., etc. Okay, you can try on this one, all right, at your own time. Okay, all right. So anasema hapa a NAND gate is more or is actually similar to a negative OR gate. So negative OR gate, that means A bar plus B bar. That's the same as a NAND gate, exactly the same. They will have the same output, right? Okay, so you can come and do this example here on your own, all right. And then we have expression for a NAND, logic expression for a NAND gate, AB bar, exactly. It's an AB bar, okay. So yeah, so unaweza ukafanya check up ya haya maswali hapa. I think umeshaona the working principle and the operations. You can do this check up on your own. You can just pause the video and do the check up on your own. Then you have the NOR gate. Then the NOR gate, that means it's an OR gate with an inverter, right? An OR gate with a bubble here means a NOR gate. Ama an OR gate and an inverter, that means a NOR gate again. Ama not all. Okay, so what's the working principle? It says for two input NOR gates, output X is low when either input A or input B is high, right? Or when both A and B are high, etc., etc. So if you look here, kungekuwa na normal OR gate hapa, a 0 plus 0 is supposed to be 0. But then since it's inverted, then we have a no output as 1, which is a high, right? You can look here at the truth table. A 0 and a 0 gives a 0 on OR gate, but if you invert it, then you have a 1, that's a NOR gate, all right? All right, so this here is a waveform of a NOR gate. You can do this on your own, all right? So a negative end is equivalent to operation of the NOR gate, yes. So a NOR gate is exactly the same to a negative end gate. Tuliona kule NAND gate is a negative OR gate, and then hapa tunaona a NOR gate is a negative AND gate, so they are exactly the same. Okay, you can do this example here on your own and see if you can get such a result on the output. So this here is a logic expression of a NOR gate, A plus B bar. That's an expression of a NOR gate. And then we have these special gates called exclusive OR and exclusive NOR. So what's the working principle? So exclusive OR, so this here is the symbol for an exclusive OR gate, all right? Uh, so anasema what's the working principle? For an exclusive OR gate, the output X is high when input A is low and input B is high, or when input A is high and output input B is low. Manake if A and B are different, input A and B are different in signal state, then the output is high. Kwa mfano hapa A and B is 0 and a 0, they are the same, so output is low. 0 and 1, they are different, so the output is 1. 1 and 0, they are different, so the output is high. 1 and 1, they are the same, so the output is 0, and etc. So for example here, you can do this. And then an exclusive NOR gate, that means not an exclusive OR gate. Okay, so the same. So tuna flip to combat to if the input A and B are different, then we have a low on the output. If they are the same, then a high on the output. Voila, I think you have understood a lot on this logic gates, and I believe that umeelewa logic operation principles. So on the coming sessions tutaanza sasa kufanya logic operations using Siemens. Okay, so tutafanya Siemens logic operations, tutaangalia AND gate, tutaangalia inverters, tutaangalia AND gate, tutaangalia OR gate, tutaangalia NOR gate, NAND gate, tutaangalia exclusive OR gates and many more. So kwenye Siemens PLC tutaangalia many more things, tutaangalia counters, tutaangalia time delays, delay timers, tutaangalia math operations and many more. So nilikuwa nakupatia to this a small introduction on logic gates in digital electronics, ili pale ambapo tunaanza sasa kufanya Siemens PLC ladder diagrams, you have this some introduction, some basics on digital electronics or logic gates. I hope you have enjoyed the lesson. Till the next lesson, ciao.